Hello students, how are you all? Our topic is Newton's laws of motion. Yes, we'll discuss about some laws of motion given by Newton, Sir Isaac Newton. First, let me start with an example. Say, I'm giving you a ball. Say cricket ball I'm giving you. You have taken the cricket ball and keeping on the table or on the floor you are keeping, and you are coming tomorrow and nobody is there. Nobody is there, and actually nobody is there to touch the ball. Just ball is kept and you are coming tomorrow or day after tomorrow or after a month. What do you find? That the ball is still there because nobody is there to touch the ball. Actually, what I want to say you that until and unless nobody is there to move the ball will be at rest. You understood my point? Good. Now, second example. You are taking the same ball and you are rolling on the ground. What do you see? It's rolling on the ground, and after some time, after covering a particular distance, the ball will come to rest. Why? Because when the ball was rolling on the ground, then the frictional force between the ball and the ground is forcing the ball to stop. You got my point? I repeat. When the ball was rolling on the ground, then the frictional force between the ball and the ground is forcing the ball to stop. Got it? Now, if that frictional force is not there, say the ball is rolling on a ground where the frictional force is not there, then correct, the ball will keep moving continuously with the same speed. Okay? So, what we discussed in two examples, let's repeat that. First, I told you, when an object is at rest, it will be at rest until and unless you are applying a force on that ball. And when a ball is moving, then the ball will keep moving with the same speed until and unless you are applying a force to stop it. Fine. This is the first law of Newton's laws of motion. So now we know first laws of motion. What is the first law? When an object is at rest, that object will remain at rest, and the object which is in motion, that will be in motion, continuously be in motion with the same speed until and unless you are applying a force to stop that ball. Got it? This is Newton's first law of motion. Don't forget. Now we'll discuss Newton's second law of motion. But before starting second laws of motion, we have to know momentum. Momentum is a new term for you. Momentum is very simple. The idea is very simple. Momentum means your mass and your velocity. When an object is moving, then we have to multiply the mass of that object and the velocity of that object. If you are multiplying the mass and the velocity, the product which you are getting is called momentum. Now say, I am at rest. See, I am not moving, I am at rest. What is my mass? Say my mass is 60 kg. What is my velocity? 0. Because I am not moving, my velocity is 0. So my mass is 60 kg, my velocity is 0. Mass into velocity, multiply it. 60 into 0. 0. So my momentum is 0. If I am running with a particular velocity, if I am running, then my mass 60 kg into my velocity. If you multiply, you will get momentum. Got it? So momentum means mass into velocity. Fine. Now, say an object is moving. Let us draw it. You'll understand better. Let an object is moving. This is the object which is moving in this direction. Say velocity is u. Fine. Now what you are doing? Say this object is already moving with a velocity u. Now from here you are applying another force, capital F. You are applying another force. What will happen? The velocity of the object will increase. Correct. So you saw that suddenly its velocity became v, and v is greater than u, because the object was moving with a velocity, but when you are applied a force, the velocity is increased now. Velocity is v. If the mass of the object is m, then what is the initial momentum? Initial momentum. I told you momentum means mass into velocity. What is the mass? M. What is the velocity? U. So initial momentum equal to mass into velocity, mu. Now if I ask you what is the final momentum? Final momentum. Final momentum. What is the final momentum? Mass into velocity. Mass into velocity. mv. Now if I ask you what is the change of momentum? Change of momentum. Change of momentum means what was his initial momentum? mu. What is his final momentum? mv. If I ask you, yesterday you had 5 rupees and today you have 7 rupees. What is the change? 2 rupees. That means what was the momentum? mu. What is now? mv. So what is the change? mv minus mu. Correct. So change is mv minus mu. Understood? Fine. Now say you have applied the force. You are applying the force for t second, because when you are applying the force, a time is taken. Say the time is t. So if the force is applied for t second, then we can say that if the change of momentum is this, then what is the rate of change of momentum? Rate of change of momentum. Rate of change of momentum means what is the change of momentum? mv minus mu by the time for which the force was applied. What is the time? T. So by t. So this is rate of change of momentum. And what Newton said? Newton said that this rate of change of momentum is directly proportional to the force applied. This force. Got it? Newton's second law of motion. Now, so according to Newton's second law of motion, the rate of change of momentum is directly proportional to the force applied. Fine? Because if you increase the force, then this value will increase. If you decrease the force, then this value will also decrease. That's why they are directly proportional. Got it? So according to Newton's second law of motion, the rate of change of momentum is directly proportional to the force applied. Understood? Now Newton's third law of motion. For Newton's third law of motion, if I if I give you another example, say suddenly your friend has come and he slapped you. What you will do? You will also slap him. This is Newton's third law of motion. So according to Newton's third law of motion, every action, there is an equal and opposite reaction. Action, reaction, they are equal. It should be equal and opposite. If this is in this direction, then reaction will be in this direction. Got it? Now, another example. If I say you that I have to punch on this wall. Say I'm punching. If I punch this way, slowly, then I'll get less force. But if I punch with a speed, with a higher speed, then I'll get more impact. Because my action was faster, so my reaction is also faster. This is action, that is reaction. So action and reaction both are equal and opposite. I mean opposite in direction. You understood? So we discussed Newton's 3 laws of motion. The first law is when an object is at rest, that will remain rest. And the object which is in motion, that will remain in motion with the same speed until and unless you are applying a force to stop it. Second law. According to Newton's second law of motion, which we have already discussed, the rate of change of momentum of an object is directly proportional to the force applied on that object. Now third law. Every action there is an equal and opposite reaction. Understood? These 3 laws are there for Newton's laws of motion, which we have already discussed. I hope you understood. Thank you.